AI project for that. Maxim and Nikita working together on the first of n lines of code. Maxim starts working immediately and writes its lines for R until the very end. So n lines of code. If we write n lines of code, the number of R's would be n upon x, written by Maxim. If there are two options, not use AI and write from the very beginning at speed of y lines per hour. And by y, if she writes n lines of code, spends that hours first setting up an AI agent, writing nothing during that time interval, and then write at speed of 10 into y lines per hour. Okay. Nikita makes this choice before work begins. It does not change it later. So this is the choice. We have two choices, whether to use AI or whether to not use it. While Nikita is setting up the AI, does not have any code at all, but Maxim continues working at speed of x lines per hour. Okay. Let us consider complete as soon as Maxim and Nikita together have written at least a lines of code. So both work in the same file, and as soon as the total code length, the total number of lines in the code exceeds n or is equal to n, greater than or equal to n lines of code, then the project can be considered completed. Project can be considered completed as soon as Maxim and Nikita together have written at least n lines of code. Project can be completed before the AI setup ends, so when the work ends at that moment. Okay, so if maxim has very high value of x lines per hour, that is, x is very high and z is very high. It takes a very long time to set up an agent, and during that time, if Nikita opts to set up an AI agent, then z hours will be wasted. And in between that z hours, if x is enough, x is sufficient to cover the length of code, then the project can be considered completed. That's the meaning of this line. If the project can be completed before the age depends, the work ends at that moment. Time is measured using full hours. If the project is completed in the middle of an hour, this hour is counted fully. Okay, so okay. Nikita has to choose whether to use AI or not. Determine the minimum number of full hours after which the project can be considered completed. Can be completed. Test cases 100. Okay, if Nikita acts optimally. So here we have two choices. Okay, two choices. If without using AI, Maxim writes X lines in 1 hour, Nikita Y lines in 1 hour. Total lines required together is N. If we don't use AI. Okay. Mhm. X lines in 1 hour, Y lines in 1 hour. Total number of lines required is N. How much time would they take? So in 1 hour, we can write X plus Y lines. So X plus Y lines can be written as 1 hour. Okay. So n lines can be written in 1 upon x plus y into n. It is n upon x plus y hours. If not using right, the answer is n upon x plus y. So what is the input? N, x, y, and z. And x, z, t, and case 1 is not using. Case 1 is not using. So its contained answer is equal to n upon x plus y. And answer 1 is answer 1. Now we will take answer 2 and we will see out the minimum of answer 1, 1 and answer 2. This is time required, um, AI agent is it can be the time required when AI agent is used. Using AI agent first get hours X into Z numbers. If X into Z is given equal to 10, then that's not done. So Windows made hours. Windows made hours if at any time the uh, work is completed by maximum amount, then what will be the is done where that is up to which will be the so it is up to 10,000 itself. N lines between uh, X lines पर से कहाँ हो गया Z hours पहले Z hours में तो ये होता है वो जो होती है कोई साथ देगा नहीं उसको only will be 0 to N maximum इसमें जो hours लगा है N by X hours लगा दिए अगर वो N by X less than equal to Z मतलब N by X is within Z hours and we will return N by Z N by X we can take it to 0 and we can uh, write if N by X is less than equal to Z this quantity is less than equal to Z then we can make answer 2 is equal to N by X. Yeah, what's having a picture? If Z if N by X exceeds Z, alone maximum won't be able to do the works in Z hours. Then the AI gender, what will be the speed per hour after Z hours? After Z hours, we consider that uh, after Z hours, uh, 10 into y will be the speed of Nikita plus x to the speed of maximum x plus 10y will be and during Z hours how many lines are written x z lines are written x z lines or written उसके बाद ये स्पीड होगी पर n minus x z the number of lines remaining and the speed is x plus 10y speed is many लाइन से पहले दिन पर आर लाइन्स इसमें आप सॉल्व करेंगे। आप और लगेंगे ना, तो एडिशनल आवर्स जब रात में गया ना। This is case 2, within answer 2. If action is not able to complete the work within the task and he needs help. So Z hours can't be building work, Z hours will be added in time, and how many lines are left? N minus x lines are left. And speed is x plus n by 1. So to solve this, zx plus 10 zy plus n minus xz upon x plus 10y. Xz is cancelled. 10 into z into y plus n upon x plus 10 into y. Still 6. The answer 2 is equal to 10 into z into y, or we can write n plus this upon x plus 10 into y. This entire thing is divided by x plus 10 into y. So if this is done, then what is the output? First test case is giving 0. The test case remains consider 10 upon x plus y if no agent is used. So n is 1. We have to consider full R now. Consider, consider full R. So we have to write ceiling of n upon x plus y. No? Ceiling of n upon x plus y. Ceiling of a by b is a plus b minus 1 by n plus x plus y minus 1 by x plus n plus x plus y minus 1 on x plus y. Let's check the first case. If possible or not. Yes. Third test case. This one. Mm, n upon x plus y. 3 upon 2. 3 upon 2 series 2. If A is not used, it will take 2 hours. That's the output also expected. Answer 2. N upon x. N upon x is what? 3, 3 is less than equal to z. This won't execute. We come to else. Answer 2 is equal to ns3 ns3 10 into z 10 into z 10 into z into y divided by x plus 10y 3 plus 10 divided by 1 plus 10 is 11. That is 13 by 11. That is 1 now. 13 by 11 should be 2. Right. So we have to again take C of this one. C is C of A upon B is A plus B. A plus B is this. A plus B minus 1 by B. This is numerators. If we run again, middle of an hour, the art form is fully. Um, 1, 1, 2, 2, 3, 4, 2, 8, 30. This 4 and this 1 is not matching. Nah, this 4 is 1, 2, 3, 4, 5. 2, 3, 4, 5. This is giving uh, 2, but answer is 4. 38 comes. Right again. 10 is equal to 30, x is equal to 8, y is equal to 1, z is equal to 30. So answer will be n upon x plus y, 9. Ceiling function of this 9, these are 9, 4. So it will be 4 parts. And that's the answer also. Answer will be n by x, 30 by 8. So equal to z is 30. It will be ceiling also now n plus x minus 1 by x, n plus x minus 1 by x. Divide ceiling will be 8 to 24, 8 to 24, 8 to 24, 4 आया नहीं 4 is equal to 39. Yes, answer to would be n by x would be this na. Okay, n by x. Like feeling everywhere na. That's the issue. If we done again, we have passed test cases. Uh, let's submit. Input code, problem A, event, accepted. Problem B, different distances. Construct an array of 4n integers such that each number 1 to n appears in the array exactly 4 times. So you can write all these things. Problem B, construct an array of 4n integers. If 4n integers are required in the array, each number 1 to n appears exactly 4 times. 4 times. Let P of x comma I be the position of the ith occurrence of number x in the array. Then for each x from 1 to n, the numbers P of x2 minus P of x comma is the second occurrence of x minus first occurrence of x, comma third occurrence of x minus second occurrence of x, comma fourth occurrence of x, index of the fourth occurrence of x minus third occurrence of x. So 2 minus 1, 3 minus 2, 4 minus 3 must be pairwise distinct. Okay, so all the four occurrences, all the four indices where the element x occurs should follow this condition that the contributive difference between the pair of indices should be pairwise distinct, should be distinct for each x from 1 to n. Okay. Mm. For example, for n equal to 3, one possible array is this array because we have to take 1, 2, and 3, the three elements 1, 2, 3, 4 times each. So 1 comes 4 times, 2 comes 4 times, 3 comes 4 times. Because one possible array is this, because if you take element 1, so the second occurrence of 1 minus the first occurrence of 1 the difference is 1. Okay, and the third occurrence of 1 minus the second occurrence of 1. If it's the third occurrence, this will be second occurrence. Difference is 2, yes. And the fourth occurrence minus the third occurrence will be distinct from 1 and 2, it is 3. All numbers are distinct. And same for the element 2 and same for the element 3. Okay, okay. So we have to construct an array like it will be given n, which is from 2 to 200. Okay. For each test case output to required array, if there are several suitable arrays, output any of them, it can be shown that at least one suitable array always exists from the concept of the problem. Because if we have to construct a constructive solution. Mm, for equal 3, the answer is this. 4, the answer is this. 5, the answer is this. So, how can we solve this? Let's take the example of an equal to 4. Let's take an example of an equal to 4. We need 4 pencils, each of 1, 2, 3, 4. Like that. Similar things. So let's consider for the element 1, if we place plus sequence 1 at a position I and the next sequence of 1 just after it I plus 1 and the third occurrence at I plus 3, fourth occurrence at gap is 1, the gap is 2, gap is 3, I plus gap is 1, 2, and 3, I plus 6. Then consider 2 minus 1, which is 1, 3 minus 2 is 3 minus 2 is 3 minus 2 is 2, and 4 minus 3 is 3. For every element, can we do this? If we start with that 1, 1, and we have a gap here, the right one here, 4, 5, 1, here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. Now we have solved the one. Now we come to 2. Can we start it from there? Yes, remaining gap. Yeah. when we do what we said, what we said is the mean of placement of animals. Mm, what- 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 in- Foundation can run now. Hello? We died like this. One was no. One, two, three, four, five, six, seven. One, one, two, three, four, five, six, seven. It's a color perfect one. हेलो हाँ मैं क्लास है ही नहीं यार एक ही क्लास थी यार वो भी ऐसे हो गई हॉस्टल में हूँ वेडनेसडे को क्लास नहीं होती कम होती है यहाँ पे खा लेना खा खा ले फिर और सब लोग बोलते हैं करते होंगे ना one, one, two, three, four, five, six, one, one, two, three, four, three, four, two, one. Okay. First, one, two, three, four, four, three, two, one, one, two, three, four, one, two, three, four. One, no, this, no, this is one, two, three, four, five, six, seven. One gap, one, two, three, four, five. No. Four are distinct, two connecting. Uh, three dots. Put one, two, three, four, five. Five gap. One, two, three. One, two, three. Four distinct. Except for three, three. One, two, three. One, two, three, five. Fine. Can write one, two, three, four. Four, three, two. Now. One, two, three, four. Oh, not four, three, two. Now something else. Again, one, two, three. That's working now. It works for n equal to five also. Or n equal to three, so stick three, two, three. So one equal to three, I one, two, three, each four times. One, two, three, three, two, one. 1, 2, 3, 1, 2, 3. Right, like this. Two is gone now. Two is gone. Three is okay. Two is gone. Huh? Two will come in after equal gaps every time. Because complements are order. You can take an equal to 4. Then it will go. Take an equal to 3 or 5. Then इस केस में 3 फेल हो जाएगा. इस केस में 2 फेल हो जाएगा. If we take n is 2, 1, 2, each 4 terms. Even n, 1, 2 is 1. 1, 2, 1. Can we do? Yes. Yes. So we have found a pattern like here this n now. See n. You can write if n is even, then we can print when you can print a pattern like 1, 2, 3, 4. For example, when equal to 4. 1, 2, 3, 4, 4, 3, 2, 1, 1, 2, 3, 4, 1, 2, 3, 4. Right. So you can print 4 and I equal to 1, I less than equal to n, I plus plus. We can print C out uh, I space. Again, we can print 4 and I equal to n, I get then equal to 1, I minus minus. Can again print, we can like this. C out I again 1, 2, 3, 4, 4, 3, 2, 1 will be printed. Then this one, this one. Then we have to repeat this 2 times. And we can return. We run this one equal to 4. So 3, 4, 4, 3, 2, 1, 1, 2, 3, 4, 1, 2, 3, 4. Oh, that's for that works. If n is even, if n is odd, you have to find out what the middle number is. N is odd, like n equal to 3 or 5. Who is the middle element? Every odd n will have one middle element, so we have to make sure that it doesn't get it. Can I 1, 2, 3, 2, 1 shortly? After the next two blocks, can't write 1, 2, 3, 1, 2, 3, can't write 2, 1. We have to start from this middle. 2, 1, 3, 2, 3, 1. Or we have again this is failing now 2, 3, 1. We have to start and we have to end like 1, 3, 2, like that. Or 3, 1, 1. Right. Then 1 will fail now. 3, 1, 2. If we write 3, 2, then again we get the big 2 elements. Number of two. If we write 1, 3, let's check if this works. 1, 2, 3, 3, 2, 1, 2, 1, 3, 3, 1. Got 1. It's working. 1, 2, Two is twin, one is twin. For two, it's looking again. Three, for three, it's not working. None. This one was you want to something else for or what can we do? The answer for equation. One, one, two, one, two, three, one, three, two, two, three, three. You can combine two elements. No, one, one. Somewhere we have two, two, and some this we have three, three. Can't write one again. If we write one, something like uh, one, two, three. ये काम कर रहा है element 1 2 3 4 5 5 4 3 2 1 1 2 3 4 5 1 2 3 4 5 for 1 for 2 for 3 for 4 for 5 8 number 1 1 2 3 4 5 6 7 8 1 then this 2 8 1 12 without information 4 4 elements between 6 elements between 4 elements 4 elements 2 elements 5 2 elements between March 7 8 elements between but 3 is only it can work this 3 this 3 this 3 and this 3 time can change this electron recent things for one gaps the gaps 1 2 3 so 0 1 2 3 4 5 6 7 8 9 10 11 13 14 15 16 17 18 19 for one there is 9 9 it is 9 uh 1 1 9 है together so the difference is 9 1 15 पे है ना 5 will become 1 5 and so when two gaps are 7 3 5 3 5 7 8 24 5 four gaps are 2 four gaps are 3 7 5 four gaps are only 3 5 7 gaps 14 minus that is 9 is 1 5 and is 3 5 5 and carry some swap it enabling elements this swap it enabling elements next element 1 2 4 3 5 5 4 2 3 1 1 2 4 3 5 1 2 2 3 5 again we are getting the four elements of it so we have started again graph this three with that also for the then swap it will be 1 2 3 4 5 5 4 3 okay 2 1 1 2 4 3 that is 5 there 4 given 5 there. Now in a swap already. Now 1, 1, 2, 4, 3, 5, 1, 2, 3. 3 images. So swap only once, right? Don't swap here. You swap just once. The other is swap the first time only. 1, 2, 4, 3. 1, 4, 3, 5, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, and 2, 3, 4. Then also it will work, right? Now you have 3 levels in between, you have 4 elements in between, you have 4 elements in between. To swap the second and third, plus 3, 4. Tablet like this. Have the third occurrence of 3 once the right 3 elements with 3 given. And what about 1? 1 is valid or not? Yes. 2 I don't. Positive 4 elements with 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 2, and 3 can 3 is working now. 4 elements in between. 5 elements in between. 4 is working on now. 2 elements in between. 5 element. 5 element. 4 is not working. Not working. It's often is not right. So how can we ensure about streams? Yes, it's from the happen causes the problem. Essence. More very right mobilizes. One, two, three, four, five, six. One, because after four elements, there are three four elements as well. This learn was very well. Then let's start with one one. Start with not to do this six. Not all the 16. The minute minute elements on that two on the on the is three together. This will work. One, two, three, four, five. One, two, three, four, five. The top of the main three, three. There is seven, six. One after four elements, that's like six elements. Two after four elements, again three after four elements. It is a pattern, but here after two elements, it works. Four after four elements, here it makes eight. Five after four elements, here it makes eight. This works. This works fine. I think this is works. So so far, in equal to one, is still equal to n five is plus. Again, this same line and start with the mid element. The mid element equal to what 5 plus 1 by 2. It's okay. By 2 times. Times, let's see, then the remaining elements. Remaining elements would be how many? For equal 3, we write this. We start with 2. For equal 3, we start with 2. So for, then we write remaining two elements. 2 minus 3 minus 1 that is 4 units. 5 minus 1 units. So the remaining 4 elements. Remaining n minus 1 elements. Remaining n minus 1 elements. Can do this. So 1 n equal to 1, I is equal to n. This plus, you can say if I not equal to mid divided with 3 in this in the case of n equal to 5, you can do this thing. For 1, 1, 1, 1, 2, 2, 4, 5, 6. If we run this, um, so we will need to further next line. No, sorry. We write here j, not j equal to 1, j into j plus plus c out I. Yes. Uh, here we have to print the next line also. Mm. For n equal to 3, we have 1, 2, 3, 1, 2, 3, 2, 2, 1, 1, 3, 3. Okay. 4, we have 1, 2, 3, 4, 4, 3, 2, 1, 1, 2, 3, 4, 1, 2, 3. For the even case, 5, we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 3, 3, 1, 1, 2, 2, 4, 4, 5. Let's try to subvert this effect. What's it works, but it was time consuming. Cost for bracket sequence. You can see that the cost of an arbitrary bracket string B, the length of its longest subsequence, that is a regular bracket sequence. You're given a bracket string S and an integer k. Your task is to remove at most k characters from the string S so that the cost of the resulting string is minimized. Okay, so the cost is defined as the longest subsequence length, that is the regular bracket sequence of any arbitrary bracket string. So there is a string S which has arbitrary brackets, parentheses only, and we define the cost of that bracket string to be the longest subsequence length, that is the regular brackets. We are given a bracket string S and an integer k. Task is to remove at most k characters from the string so that the cost of the resulting string is minimized. Constraints are less dynamic programming will be used here. For test cases 10 power 3, we have 2 seconds time limit per test. That means 2 into 10 power 8 iterations per test, and each test contains multiple test cases, and each test contains at most 10 power 3 test cases. So 2 into 10 power 8 divided by 10 power 8, 2 into 10 power 5 operations per test case are allowed. 2 into 10 power 5 operations per test case are allowed. Okay, and sum of enable all test cases do not exceed 5,000. Can remove at most k characters. Cost of this resulting string is minimized. You have to remove some elements where the length of the regular bracket sequence within the string is minimized. Minimized. Here the string is this. There is no balance pencils or cost is zero because cost is defined as the length of the longest subsequence of the string S, that is the regular bracket sequence. It is not the regular bracket sequence. It doesn't contain any regular bracket sequence as a subsequence as well, so the cost is zero. So you don't remove this and don't remove the second element as well. Because the skills are possible string are already zero, so it is possible not to return it. Yes, in this case, we have a regular bracket sequence. We have to minimize the cost. Cost we have to minimize the length. If we remove one element, but k is zero, you can't remove anything. K0 can't move anything, so answer is again 0. If K is 0, then answer is 0, 0. That is confirmed because we can't remove any characters. This case 4 and 1. One key, one more is without, and this is a completely balanced. So the current cost is 4. So the length of the subsequence is here subsequent as well is 4. If we have to break the uh, subsequence, if we have to break the regular bracket sequence, so we can remove, if we remove this, if we remove this, the cost will be 2 again, because this was a regular bracket sequence, this will remain. This won't be balance, but it should remain. Okay, so, and you have to allow to remove only one character. So, if we remove this, then cost is 2, and the cost is 4. If we remove this element, again this will be balanced, cost is 2. If we remove this element, again this would be balanced, the cost will be 2. If we remove this element, again the cost will be 2. And we have to remove only one element. If we had the privilege to remove two, at most two elements, then we could have removed these two and the cost would be 0. But currently the minimum cost we get is 2 to remove any one of the force. The third case possible impossible to obtain a string of cause 0 after one deletion. It is possible to obtain a string of cause 2 when deleting any characters. Yes. Okay. If we have this, glance of this, this is balance. Length is 2. We have to remove one element. So if we remove this, cost will be 0. That would be the best possible. If we remove this, cost will still be 2. If we remove this, cost is still 2. If we remove this, cost is still 2. Remove this only. So 1 you will remove. Again, cost will be 0. Again, this is completely balanced, right? No, this part is balanced. We have to remove only one element. So if we remove this, no change will be there. The length is currently 4. If we remove this, no changes because this will not balance this. Length is 4 again. If we remove this, length is 4. If we remove this, now the length is 2. If we remove this, now the length is 2. Any one of these two can be removed. Any one of the closing brackets can be removed, not the opening ones. If we remove any one of these, the cost will be 2. So 0, 0, 0, 1, 0, 1, 0, or 0, 0, 0, 0, 1. Can use answer as well. Just this case. This, well, okay. So we have to remove the outer one first. But the use of removing the inner one, because this it can be balanced, right? This can be balanced. Outer one closing. Outer closing is more. Outer opening because there is opening there. If there was separate closing and there was not an opening, one more extra opening of people doing this. So it makes sense to remove outers. Outers. Right? Because if we remove inner, the frequency can be balanced by this now. If we remove this, then it will be balanced. If we remove this, no longer balance. This is not simple. In this case, we know this you have to. two deletions possible, then it can remove this, remove this, possibly two, or maybe one, maybe completely balanced. Now, if we remove this and this, if we remove these two, the cost will be just two. Okay, they have removed what? They have removed third one and this one. Process two can also. Now the process two. This will balance where the two ends. Right. Remove this and this. Not, don't move this. Go ahead and give it to balance. Here, don't remove this. Here you have to remove this opening and here you remove closing. Okay, then only it removes. So now, set. Then lighter goes forcing very easily. Yeah. N is quite less now. 5,000 only. But K can be up to 10. At most K characters. So ideally we would remove all the K characters. What is the limit? It doesn't harm removing cables, electric characters. Why would you not remove electric characters? Why would you keep some leftover K value? If you can remove, you may be able to further reduce the cost, right? It doesn't make sense to remove less than K characters. It makes sense to remove all the K characters. That's the upper limit we have in the removals. And the first point is that we should remove all the K characters. Which characters we should remove? That is the question. It is a brute force approach. Which characters can be removed? Suppose we are case 2. So we can iterate over every two characters. Like if we start with this, we remove these two, we remove this and this, we remove this and this. That's a n square loop. And within the loop, we will check. Suppose we remove in a particular iteration, we remove this, And then this will remove these two in a particular iteration in the nested loop. Then we will check that we will check the length. Length is 4 here, right? And to the longest subsequence, that is the regular vector sequence. That is 4 here. The cost is 4 in this case. And how would you find the length? We can use a stack. Use a stack. No stack. Without stack, no stack. That will be another order length. So overall, it would be order of n cube. And order of n cube will give the t and e and complexity. If we can make it order n squares within 11 minutes, then we make order n squares. Which is order n cube in time. Order n cube in time. We have to remove three vectors, right? We can simply remove this, then it will be also zero. But we have to use three. As said, use always. It is no harm to use all three. Can remove this as well. So what we have done. We can remove these two. Okay. If we remove these and the what will be the opening brackets, the cost will be zero. Then you can choose any one touch. Which was going to work here also. You can't just you can't run a screen of tables. Nested screen of tables. Three is not always two. Three. How many people have solved this? 8 to 6. The index is meaningless. Question 2 took too much time. Question 1 also. The problems took large amount of time. But I solved very quickly. Like, it took 15 minutes more, I think. It should have been around 10, 12 or 15. That's, the problem statement was big and it was very confusing at first read. However, it was intuitive that there were two options, two choices. First, whether to use AI, second was to not use AI. Calculate the time taken to write lines in words and then print them in form of them. Problem B was like constructive and can't do much about it. Problem three, this of time and it everything. Dynamic programming solution will work here. Dynamic programming solution can work here for sure. It can influence the actual resource. Problem C and B took a large amount of time. Sorry. I will absolve this multiple thing right now. I think the dynamic programming, uh, what would be the state if it's more dynamic programming? DP. State can define DP of I K, where when a student DP I K, which denotes the minimum cost of string S from 0 to I. Uh, if we have removed, if we have the right to remove at most k characters, so we can write dp ik ik ik. Then it would be order and squares in time. What would be the the state is defined? What would be the transition? State is also not exactly defined as vaguely defined. I will need to think about it. Then, like, a character in the both of you. Then I like this GP of IJ or right, of IJ. This denotes the minimum cost of streaming is from 0 to y, which is a substring due to L, and we have no J character till now. Something of this sort can work. Right. We need to solve this.